Hi, everyone. I'm going to be doing this talk in English today, so bear with me. I'm Maor Frankel. I'm from the Amplify Self-Serve team, and I'm here to talk to you today about making your grandparents happy. So you're probably asking yourself about now, what do my grandparents have to do with web development? Well, unless your grandparent is one of this guy, probably not a lot. By the way, that's Uncle Bob, the clean code guru. But your grandparents, just like everyone else, probably use the internet, right? And while we'd like their experience to surf the internet to be something like this, it's more probably something like this. And the reason for that is because your grandparents are real users, right? And real users use medium or old mobile phones or medium old computers. Maybe they have slow internet connections. Maybe, they're sitting in a coffee shop with hotspot. So the experience that they get as users is very different than the experience that we get as web developers, right? Because we as web developers use strong MacBook Pros or something similar, Surface 2. And the experience that we have as developers is very different. We use strong internet connections. We work in an office. Sometimes we're sitting in our own data center. And the data that we use is not the same. I mean, in the dashboard, some of our accounts have tens of thousands of campaigns, hundreds of thousands of ads, and millions and billions of conversions. So the experience that we see while we're developing our application is very different than what our real users have. So the question is, why don't we as developers accommodate for real users? Well, there's probably two answers to that question. The first one is, maybe you don't care, right? Maybe your target audience is enterprise users, which also have strong computers, they have strong internet connections, and you don't think that they suffer from the same things that other users might have. Well, that's a good point and it's valid, but you got to remember one thing, that even enterprise users sometimes sit in a coffee shop. Even Mark Zuckerberg maybe has a coffee and uses his hotspot. So the experience that he's getting at that point is possibly not ideal. Another reason that you might have for not doing this is probably the more common one. You don't know. You don't know what your real user's experience is. Maybe some of us as developers open our dev tools if we're responsible. We do a little bit of network throttling. We do some mobile phone emulation, which is very important. But again, you're not getting the real picture of what's going outside. So, on top of that, web applications today are getting bigger, right? They're getting bigger, you're getting more code, more features, and that's causing the web applications to be slower. So the situation right now is, even if it's good, it's just gonna go get worse over time. And that's the story that we had here at Outbrain. We had a new web applications that we wrote. It was optimized for performance. It was working great. We released it to production. Everything was golden. But over time, it became bigger. New developers came in, they added new code, new features. We introduced a lot of third-party libraries, bugs came in, et cetera, and obviously that got slower over time. Now, like I said, we didn't see it in our computers, but even what we did see as far as performance, we were in denial. We didn't want to realize that we had a problem. We wanted to write features, we wanted to play with new tools. So, we had all the excuses in the world. It's localhost, I'm working my local computer, the database has latency. We didn't want to fix the problems. We wanted to write features. Until users started to complain. Now, a point about this, generally, users are not going to complain, especially about things that are related to performance. Because if they go into your web application or your website and they see it's working slow, they're probably going to think, maybe it's my internet connection, maybe my computer isn't very good. Or they're just going to say, well, I'm just going to move to a different web app, a different competitor. So the fact that users are going to complain, don't take that for granted. If they do get to complain, it's probably pretty bad. And in our case, users did complain. So we had to do something about it. What were you going to do? Well, first thing, put out the fires, right? We have a problem, let's fix it. We went to the code, we fixed all kind of bugs. We did some optimizations on our API calls. We made our API calls parallel to the page loading. We introduced lazy loading, which had a significant improvement on performance. We expedited the removal of Angular JS. We were working in hybrid mode, which had a very bad impact on performance, and that it did a lot of improvements. Just to give you an understanding, we had about 20 seconds loading time on the application when we started, and we managed to bring it down to about 8 or 9. So that's a huge improvement. It's still not good enough. We're still working on it. But again, 50 or 60% improvement is very significant. So that was good. But the better question we had to ask ourselves was, why did this happen? How do we get to this situation? And how do we prevent it from happening again? So the answer was obviously something to do with monitoring. So we looked at the monitoring that we already had in our stack. I imagine most people already have something similar. We had availability tests, which are basically making sure that all our APIs and all our services and all our servers are up and running. We even have tests that log into our application into production and see that it's up and running. So that's very important, but that doesn't tell you a lot about the performance of the application, right? We had functionality tests and functionality monitoring that made sure that all the endpoints and all the features were working as we expected. Again, doesn't say, very important, but doesn't say much about performance, does it? API monitoring, similar. And we also had synthetic performance tests. Synthetic performance test is what you do when you log into your dev tools and try a bit of throttling. We even had tests that logged into our application and made sure that it started in loaded in a relatively decent time. And that's important, but you'll see later on, there's a huge difference between having a test that logs into your application within your data center and checking with maybe mock data or small data than what your real users are experiencing. So these were all good, but we were still missing something. Sorry. And this is what we were missing. We were missing real data from real users in real time, right? We wanted to know what our users were experiencing when they were working our application, because we ship a web app to production, it gets downloaded to the user's page, and we don't know anything about what's going on over there. We have no idea. It's called real-time user monitoring. There's even a term for it, RUM, and that's what we were missing. So, like all developers, we wanted to see what was out there, what we could use, what we could take off the shelf, you know, plug and play, and maybe have a quick solution for it. And there are options out there. Google Analytics, they give some analytics on the page load and different performance performance matrix that you can get. Raygun, it's the client tracking error system. Maybe you have something different, but they have the ability to add some performance insights. And New Relic browser, they also have something. If you're using that, then you can tap into that. So these are good, but they have a couple of problems. The first problem is they cost money, right? Even though it's not our money, but you know, it's still your company's money and you need to take that into account. And the second problem that was for us more significant is all these solutions give you a very general idea of performance monitoring. They give you some vague matrix about how your application is performing, but every application is different, right? Every application has its own bottlenecks, its own areas where you know maybe your application is not working well, and that's what you want to be checking. So even it might give you an idea that you have a problem. It's not going to give you a lot of information about what the problem is and where it's coming from and how to solve it. For instance, Google Analytics gives you a matrix called average page load time. What is page load time? What does that mean? Thank you. So average page load time in Google Analytics is defined as, this is the time it takes the page to load. It begins when the navigation begins and ends when the web page is completely loaded in the user's browser. That doesn't say very much, does it? What does it mean when the user's page is finished loading? So Google Analytics basically wait for the DOM content loaded event. And the DOM content loaded event fires when the initial HTML document has been completely loaded and parsed without waiting for style sheets, images, and subframes to finish loading. I don't know about you, but for a user, that's not really a page load. For us, our definition for a page load was from the minute the user started his navigation till he could actually interact with the web application. What's the point if this event is fired, but the user's sitting and looking at a preloader for 10 seconds? I mean, he doesn't care that that event was fired. He wants to work. So like I said, all these metrics that they give you, they're not necessarily relevant to your application. So we decided to build our own. We decided to build something on our own, and we decided to leverage our existing systems in Outbrain. Luckily, Outbrain has a very robust monitoring infrastructure. I imagine most companies in most places do, and we decided that we were going to leverage that. So we made a plan, and this is the basic layout of how it works. You got your user surfing his favorite browser, or everyone's favorite browser, and he's working on your web application. And while the web application is working, it's sending matrix back. It's accumulating and measuring all the performance matrix you want to measure, and it's sending it back to an API. API, just a server endpoint waiting to get the data. Once it gets all that data from the user application, it's going to push it into a data store. In our case, we use Prometheus, which is a monitoring database. It's free, it's open source, it's released by SoundCloud. Again, if there's lots of options out there, this is the one we use. If you're not using anything else, Prometheus is a good recommendation. And once we have all that data accumulated, we can start building our monitor system, our graphs on it. So again, in Outbrain, we have Grafana already in place. Again, free, open source, doesn't cost any money. You can put it in unless you have something of your own. And we start building our graphs, which you'll see later. Once we have all those graphs in place, we can actually see the results of all the data that we've accumulated. And another side note, by the way, Grafana also has an alert system. So you can put different alerts on that say, if the page load time is increased over a certain period of time, send out an alert and let us know that something's wrong. And of course, that made us very happy. Now, there's a missing part in all of this flow, and that's how do we actually accumulate the data on the client side. Now, we've talked about Web Performance API before. I'm not going to get too much into it, but for anybody who doesn't know, Web Performance API is an API that lets you measure certain parts of your application. You can actually measure different sections, actual JavaScript code from when they started and when they finished, or different parts, and gives you a very exact and high resolution measurements. So this sounded perfect for what we needed to actually understand how our application was working. So like I said, I'm not going to go into it too much, but this is a basic example. You can see, you can call performance now, which gives you a timestamp, and you can run that before a certain function runs. You can do it again after the function is finished. And then if you see the delta, you can actually see how long that function actually took to run, 500 milliseconds. So you understand how long that code actually took to run. And of course, different functions can have different data sets, especially in production. And that way you can see the difference of how those functions run with real data. And this is a little better. Performance API allows you to add markers. So you can add different markers throughout your application and certain points of interest. If you have a certain point in your application that is interesting to you, you can just add a marker there. And later on, you can accumulate all that data. So that was a little bit about Web Performance API. Now let's see how we actually added it to our application. So this is the index HTML of our application. And you can see here that we've actually added a performance mark that says page load start. So at the beginning of the web application, just when it starts, we're actually saying, this is a point of interest. This is where the application started running. And now we can make measurements based on that. This is another area of our code. You can see here. You can see here that we've added markers where our JavaScript chunks actually start loading and when they're finished. So we can see how long it took our JavaScript to load. It's important because, first of all, it tells you a lot about the network conditions that the users are having. Maybe your JavaScripts are getting bigger and bigger, and this is starting to get larger, and you have to do something about it, like lazy loading. So this is another point of interest. We have a lot of these on the application. I'm not going to go through all of them. Here's another one. This is we use AG-Grid, which shows all our reports data, and we have a matrix that check when the report started loading, when the grid got the data and started rendering, and when it finished. So we can actually see how AG-Grid handles real data. And after you've got all those markers out, you can actually start measuring it. You can have you can take two different markers and basically ask Performance API, given the delta between these two markers. So we can see we measure CSS, how long it took our CSS to load, how long it took our scripts to load, and that's a total page load time. We can see that we check it from the minute the page started until the minutes the reports actually finish rendering, because that's what's interesting for us. Not when the DOM content load event fired, but when the actual preloader on the grid finished, and we can start interacting, the user can start interacting with his data. Once we have all these metrics accumulated, we want to send it back to our server. So we just go through all of our measurements, we add them to a specific JSON format that we want to, our endpoint expects to get. One thing you want to notice here is that we're also sending the connection speed. This is an only Chrome API, but you can actually get what the internet connection speed was the time the user was using your application. That can give you a lot of insights and help you reduce a lot of noise. We'll see a bit about that later. And once we're done all that, we can send it actually back to our server. We're using here, by the way, Navigator send beacon. Anybody know what that is? So Navigator send beacon is similar to a post request. The only difference is it actually waits until the browser has finished all kind of interactions, all network requests are finished. When all that's finished, it sends it back to the server. The good thing about that is it doesn't hurt the performance of your application, but this is a side note. You can use it just a regular post request. It'll work just as well. This is the endpoint on the server side that basically gets all the data, aggregates it into something that our data store is waiting to accept. And then this is just a Prometheus API, just pushes it into the database. That's it. Pretty straightforward all in all. So once we have all that data put together, once we've accumulated data and we know how our application is working, we can actually see the results of what we've done. So this is the dashboard that we actually have. Can you see it okay? It's pretty okay, right? This is the dashboard what we have where we work. It's on a screen, so we see it all the time. So we always know what's going on with our application, and it gives us a lot of awareness of how our application is performing. I'm just going to go over a few of the metrics that we can see here. So the first one, average page loading time. We can see how long it actually took for an average user to see and start working interaction. It sounds like a lot, but it's relatively pretty good having 6 seconds from the minute the navigation starts. CSS loading time, we talked about it before. We can see how long it took our CSS to load. If our CSS is getting bloated, if it's getting bigger and bigger, then we know that we have to do something about it. Prescripts load, this is an interesting one. This is actually, we have Google Tag Manager in our application. That means that the guys from marketing can actually add third-party scripts to our application without going through us, which is good because that allows them to work free. But until this point, we didn't know what was going on. We didn't know what they were putting in. We didn't know what effects that had on our performance. And after this, we could actually see. If you see the spike over here, we could see that they added some script that basically had a bad impact on performance. And we could go and say, hey guys, are you sure you need this? Because this is affecting our loading time. Script loading time, again, we saw that before. We can see how long our JavaScript take to load. And an interesting one is Angular load time. This tells us how long it took for Angular to bootstrap, which is very important, especially when we were working in hybrid mode. And you can see it's quite significant. It takes over 2.5 seconds just for Angular to do all its bootstrapping. So this is something that you can do a lot of optimizations. If you're not careful with with how you use Angular, this can get quite large. Also, we can see by geo. We can actually see the performance of applications in different countries. Again, if you see, for instance, that your application is working very slowly in Europe, Maybe you have a problem with your CDN. Maybe you need to add some configuration that's improving the CDN in Europe. So this gives you a lot of insights, not only how your app is performing, but how you can solve certain problems that some of your users may have. And we also have static file size. We can see the file size as it goes through time. We can see if people are adding code that they shouldn't have, and we can track that and make sure that it's not getting out of hand. So that was basically the few flows that we see on our dashboard. And we also have a lot of breaks down that we can do, which also help us understand how our application is performing, and more important, where is it failing. Here we can see that we have an option to see the deployments. So you see those red lines, can you see them? Those red lines on the graph basically represent the deployment. What's good about this is that we can see if somebody added bad code or something that hurt our performance, we can see that from that point, something went bad. And then we can actually track back and see who made the changes that affected our performance. You can see there's a little spike after every deployment. Those are basically cache misses. So you have to kind of wait until the cache settles down, and then you can actually see the real results of the deployment. And you can see throughout all the different metrics too, it's everywhere. Browser, you can actually have a breakdown of different browsers. How does most of us develop on Chrome, right? How does our application work with Firefox? We don't know. And this is very interesting because Firefox is generally considered a faster browser than Chrome. But you can see here that in Firefox, it takes 7.5 seconds to load. And on Chrome, it takes 5.8. So why is Firefox, which is a faster browser, take longer to load our application? Simply because we develop in Chrome. We don't optimize for Firefox. And this is a very good way to see how you don't understand how your application is performing in real life. You think, oh, if it works fast on Chrome, it must be faster on Firefox, but the reality is different. Here we can see another breakdown. So you can see how much of a difference it makes for real users. So if a user is using 3G internet connection, which is probably his mobile phone, and the quintile, the percentage is 75%, which is better. That means this is the experience 25% of our users are getting. You can see the page load is 23 seconds, so that is significant. So users who are using their mobile phone, 25% of them are getting a really, really bad experience. And these users might leave if this continues. So this is something that we had no idea before we had this. Again, you can see the difference between the percentile. Before it was 5.5 seconds on Chrome. And that means half of our users were getting that experience or better. On the 75 percentile, you can see that 25% of our users are getting a worse experience. So there's a huge difference between our users. Not everybody's getting the experience that you think they are. And here's another good breakdown that you can really see the difference. This is in simulator. Okay, again, 75 percentile, 4G, Chrome in simulator, that's 7.4. If we go back to a production environment, not simulator, you can see the difference. So if you have test in simulator, or if you're testing in simulator and you think it's working well, there's a huge difference. That's 4 seconds difference from what actually happens in production. So you can't rely on what you see in your internal environments and your internal machines. So that's basically what we have in our dashboard. We have a few other things, but basically the idea, you get the basic concept, I think. Now, like everything else, there are a few things that you need to take into account when you have something like this. First thing is noise. You're talking about a lot of data from a lot of users, and you have to, you're talking about a lot of data from a lot of users, and a lot of that is noise, okay? Maybe somebody's using a mobile phone, a Windows phone, which is, there's no point in supporting that. And the performance on that machine is gonna be drastically slower. Maybe a user opened his internet connection and went into a tunnel or the underground, and that got stuck for a half a minute or a minute, and the page load time was significantly higher. So there's a lot of fine tuning that has to be done here before you can actually see the results that are relevant for your application. So it takes a bit of time to fine tune that, but you can kind of clear out all the edge cases and get to see the real data. Another big issue is that we're talking about big data, okay? A lot of users, thousands of users sending these matrix. You have to be ready to handle that amount of data. For instance, we keep our data 30 days back. Maybe it needs to be shorter if you can't handle that amount of data. And again, in our Amplify self-serve team, we have a few tens of thousand marketers, which is not a lot. But on our widget team, for instance, I know, which have hundreds of millions of users, the amount of data is not something that you can actually do anything about. So they, for instance, do sampling. They only look at 1 in 10,000 users. So there's a lot of things you can do to work with big data, but it's something that you have to take into account because you're gonna get a lot of information. You need to know how to handle it. And a small bonus, it's not something that we actually do, but we've been talking about it a lot. And if this is something that you want to implement, maybe you can take that a bit forward and think about how to implement it. Tracking memory leaks. Tracking memory leaks is something that's very hard, especially on your machine, because memory leaks are something that happen over time, and we usually tend to refresh our browser about every 5 seconds. So for us as developers, it's very, very hard to see, are there any memory leaks in our application? We're basically blind for these kind of issues. So performance also exposes an API for getting the memory allocation at a specific point. It gives you see 3 matrix, the JavaScript heap size limit, which is the limit of how much JavaScript can be allocated. Total JavaScript heap size, which is the size of the JavaScript heap, including empty space, that's how much is allocated. And use JavaScript size, which is the actual amount of JavaScript your objects are taking up. The problem with this, by the way, it's not very precise. It can actually give you, if you have more than 1 tab running on the same domain, it can actually give you the memory for both those tabs because it uses the same renderer instance. So there are a bit of problems with this API, but it might be enough to get a basically, over time look about how your app is performance and if you have memory leaks. For instance, I know the guys on the Gmail team, which suffered a lot of problems with memory, used this and they tracked how their users were consuming memory, and they could see specific users over time had memory issues that were growing and growing and growing and caused very long garbage collection cycles. So like I said, we don't have it implemented. It's something that we've been talking about, but I think it's worth mentioning. And maybe if you have problems with memory leaks, you might want to try and implement something with that. So for us, it was a big success. First of all, we reduced our loading time from 20 seconds to less than 9 seconds. And that's in the 75 percentile. So for us, that's a huge improvement. And we keep working on that, and we can improve it more and more and more until we get to a point where we're really happy. And more important, we raise developers' awareness. Before this, we had no idea what was going on. We didn't even think about it. Unless somebody complained, unless we saw something that was really standing out, performance, it looks okay on my, it works on my computer, so it must be okay, right? So developers today, we have it on our dashboard. We're constantly looking at it. We're constantly thinking about it. Every deployment, we check out, oh, is it getting better? Is it getting worse? So we have a real understanding of what we're doing. And when we add code that improves performance, it gives us a huge boost, right? Because we can see, wow, we've lowered our loading time in 3-4 seconds. So that's a very important key for us. And also a much better correlation between changes and performance issues. If somebody deploys a code or a feature which has a negative impact on performance, we can see that almost immediately. So we know, oh, who deployed to production, what was in that code. Maybe that code had a bad effect on our performance. Now we can maybe do a rollback or understand at least what went wrong. And a few points before I finish. First of all, if you're not monitoring it, it doesn't exist. Okay, if you're not monitoring it, you don't have some visibility to it, you don't know. You simply don't know if there's a problem. Unless users complain, and like I said, you shouldn't count on that ever. Dev time is not real time. The experience that you have as developers is significantly different than what your users have. I know everybody likes to say, it works on my computer, but nobody cares if it works on your computer. The important thing is, does it work on your user's computer? So you have to keep that in mind all the time. And another small tip, before you pay for it, try to build it maybe. It's not true for all cases. Sometimes it's better to just buy it and have somebody else do the work. But there are a lot of cases where you can build it yourself, especially if you have the infrastructure, and it might be better, it might be cheaper, and you should always try and look at that option before you go out and pay for something a lot of money. That's it. Thank you very much for listening.